Hi guys! Welcome sa enginerdmath channel. Sa video na to ay tuturo ko sa inyo ang improper integrals. So kung gusto nyo itong matutunan, just keep on watching. Okay, so this time ay tuturo ko naman sa inyo ang improper integrals. Okay, so ano ba ang improper integrals? So i-illustrate ko sa inyo kung ano yung geometric interpretation natin ng improper integrals. So, as a background, kung i-consider natin yung definite integral na naturo ko naman na sa inyo sa previous video ko, let's say meron tayong graph dito given by the function y equal to f of x, and then kapag hinanap natin yung area bounded by the given curve y is equal to f of x, the x-axis, at yung dalawang vertical lines given by x is equal to a and x is equal to b. So, sa figure, itong shaded region natin yung area given by this value A. So, pwede natin gamitin yung definite integral para makuha yung value ng area natin. So, it is equal to what? A is equal to integral ng f of x dx from A to B. Actually, in general niya is y upper minus y lower. So, yung y upper natin is itong y is equal to f of x, and then yung y lower natin is itong x-axis or yung equation niya is y is equal to 0. So, pag ginawa natin yon, equal din siya sa integral ng y upper which is f of x minus y lower which is 0 dx from a to b. So, f of x minus 0 is just f of x. So, kaya, ito lang yung naging formula natin. Integral ng f of x dx from a to b. So, mapapansin nyo, yung area na nabuo natin dito is closed region, right? So, wala tayong butas. Etong area natin is bounded, right? By these bold regions. Okay? So, therefore, certain tayo na itong area natin is merong infinite value or nag-e-exist yung value niya. So, ito yung tinatawag natin na proper integrals. Definite integral na kung saan yung kanyang value is nag-e-exist. Okay? Now, kapag meron na tayong improper integrals, so, either doon sa isang limit natin of integration, either a or b, yung lower limit a is pwedeng nag-a-approach sa negative infinity, or yung lower limit b is pwedeng nag-a-approach sa positive infinity, or pwedeng both. Yung lower limit nag-a-approach sa negative infinity, and then at the same time, yung upper limit b nag-a-approach sa positive infinity. So, yung first case na kung saan yung ating upper limit b is nag-a-approach sa positive infinity, is given by this figure. So, mapapansin nyo, yung lower limit pa rin natin is given by x is equal to a. Kaso, yung upper limit natin na b is wala siyang finite value kasi nag-a-approach siya sa infinity. So, pwedeng mag-extend yung value ng b natin hanggang positive infinity, hanggang dulo. So, kapag hinanap din natin yung area bounded by the curve y is equal to f of x, x-axis, line x is equal to b, and then yung x is equal to b nga na nag-approach sa positive infinity, yung area na yon is given by this shaded region in light green or given by the value a. So, mapapansin nyo, butas siya dito sa kanan, right? So, pwede pa siyang mag-extend hanggang dulo. Okay? So, pag kinuha natin yung value ng area niya, area can be equal to integral of f of x dx, this time from a to positive infinity. So, tinatawag na natin tong improper integral. Kasi yung isa sa limit of integration natin, which is in this case yung upper limit natin, is hindi na constant, kundi infinite value na, in particular, positive infinity. Okay? Likewise, yung case naman natin kung saan yung lower limit natin is nag-a-approach sa negative infinity. Given the same curve y is equal to f of x, this time yung upper limit natin given by the line x is equal to b, and then, yung ating lower limit nga is x is equal to a nag-a-approach sa negative infinity, meaning yung value ng x natin dito is pwedeng mag-extend pa hanggang dulo up to negative infinity. So, pag ginawa natin yung area bounded by the curve y is equal to f of x, x-axis, x is equal to b, and then yung x is equal to a na nag-a-approach sa negative infinity, ito yung region na yon. Okay, given by the value a din. So, mapapansin nyo, butas naman siya dito sa kaliwa. So, pwede bang mag-extend yung area natin to the left up to negative infinity. So, yung value ng area natin kapag sinolve natin will be a is equal to the integral of f of x dx from negative infinity to b. So this time, yung lower limit naman natin, yung merong negative infinity limit. Okay? And last, kapag both naman na yung lower at upper limit natin is nag-a-approach ng negative infinity at positive infinity respectively, ito yung magiging area bounded nung given curve is equal to f of x, x-axis, and then yung dalawang line, A and B na nag-a-approach sa negative at positive infinity, sa butas yung region sa kanan at kaliwa. So, pwede siyang mag-extend to the right up to positive infinity, and then mag-extend to the left up to negative infinity. So, ang formula natin for this region will be area is equal to integral of f of x dx from negative infinity to positive infinity. Okay? So, ito yung tatlong case natin for improper integrals. So, tandaan natin na unlike sa proper integral, kung saan laging nag-e-exist or finite yung value ng ating integral, dito sa improper integrals, there will be some cases na hindi mag-e-exist yung limit. So, kapag nag-e-exist yung limit, tinatawag natin siyang convergent. Kapag hindi naman nag-e-exist yung limit, tinatawag natin siyang divergent. So, ang tanong is, paano ba mag-evaluate ng improper integrals? So, ituturo ko sa inyo. So, meron lang tayong definition or formula na susundin para mag-evaluate ng improper integrals. So, for the first case, if f is continuous for all x greater than or equal to a, then integral of f of x dx from a to positive infinity is equal to the limit of integral of f of x dx from a to b as b approaches positive infinity if this limit exists. Next, for case 2, if f is continuous for all x less than or equal to b, then integral of f of x dx from negative infinity to b is equal to the limit of integral of f of x dx from a to b as a approaches negative infinity if this limit exists. And lastly, for case 3, if f is continuous for all values of x, then the integral of f of x dx from negative infinity to positive infinity is equal to the limit of integral of f of x dx from a to 0 as a approaches negative infinity plus limit of integral of f of x dx from 0 to b as b approaches positive infinity if this limit exists. Okay, so tandaan lang natin yung mga formula na to kapag mag-evaluate tayo ng improper integral. So, mapapansin nyo sa formula natin, parehong applicable yung definite integral at pag-evaluate ng limit. So, kailangan meron na tayong knowledge sa pag-evaluate ng definite integral at limit para ma-solve natin yung improper integrals. Wherein, naturo ko naman na sa inyo yung concepts ng definite integral at limit sa previous videos ko, right? Okay, so para ma-illustrate kung paano mag-evaluate ng improper integrals, ay mag-solve tayo ng examples. For the first problem, we have, evaluate the integral of dx over quantity 4 minus x squared from negative infinity to 2. So, this is case 2 para sa ating improper integrals, right? Kung saan yung lower limit natin is negative infinity at yung upper limit natin is constant. So, yung formula natin kanina doon is this one. So, copy ko. So, gagamitin natin tong formula na to evaluate this improper integral. So, equal siya sa limit ng integral ng f of x dx. So, ito yung expression na yon, dx over 4 minus x squared. And then, from a to b, this time yung b natin is 2, right? And then, as a approaches negative infinity. So, evaluate muna natin tong definite integral. So, we have integral of dx over 4 minus x squared from a to 2. So, pwede nating i-let u dito itong denominator natin na 4 minus x. So, let u equals 4 minus x. Getting the derivative of both sides, we have du is equal to 0 minus 1 dx, or simply du is equal to negative dx. Then, divide both sides by negative 1. So, we have negative du is equal to dx. Such that, meron tayong integral of itong dx is equivalent sa negative du, and then itong 4 minus x is equivalent to u. So, magiging negative du over u squared. Right? Itong negative, igigilid ko na lang. So, minus integral of du. And then itong over u squared, pwede kong gawing u raised to negative 2. Right? Ngayon, applying yung power formula para ma-evaluate itong integral, we have negative of u raised to negative 2 plus 1 over negative 2 plus 1. So we have negative of u raised to negative 2 plus 1 is negative 1 over negative 2 plus 1 is negative 1. So cancel yung negative, magiging u raised to negative 1 na lang or 1 over u. Now, ibalik natin yung u in terms of x. So, equal yung u sa 4 minus x, right? So, therefore, equal siya sa 1 over 4 minus x. Then, tsaka natin evaluate sa lower at upper limit from a to 2, right? So, evaluate from a to 2. So, substitute natin yung 2 sa x. So, 1 over 4 minus 2 minus. Substitute naman natin yung a sa x, 1 over 4 minus a. So, simplifying this, we have 1 over 4 minus 2 is 1 half minus 1 over 4 minus a is 1 over 4 minus a. Okay? And then, i-evaluate natin tong expression na to sa given na limit as a approaches negative infinity. So, we have limit nitong 1 half minus 1 over 4 minus a as a approaches negative infinity. So, pwede nating i-distribute yung limit. So, we have limit of 1 half as a approaches negative infinity minus limit of 1 over 4 minus a as a approaches negative infinity. So, yung unang expression, dahil constant lang yung function natin dito, automatic ang limit niya is 1 half. Minus, this time yung second expression, ano yung limit ng 1 over 4 minus a as a approaches negative infinity? So, obviously, mag-a-approach siya sa 0, right? Kasi habang ina-approach nitong a, yung value na negative infinity, sa palaki ng palaki, yung denominator niya, ibig sabihin, 1 over a large value is approaching 0. Okay? So, therefore, yung limit natin is 1 half minus 0 or simply 1 half. So, therefore, yung answer natin for this improper integral is simply 1 half. So, ibig sabihin, convergent yung ating improper integral at nagko-convert siya sa value na 1 half. Okay? Next, we have evaluate the integral of e raised to negative x over 3 dx from 0 to positive infinity. Okay, so this time, case 1 naman to sa ating improper integrals kung saan meron tayong constant na lower limit at yung upper limit natin is positive infinity. So, gagamitin natin yung formula kanina sa taas na to. So, copy natin. So, we will use this formula to evaluate the improper integral. So, equal siya sa limit ng integral ng f of x dx is this expression, right? E raised to negative x over 3 dx. Then, from lower limit a, which in this case is 0, right? To upper limit b, and then as b approaches positive infinity. So, evaluate muna natin itong definite integral. So, we have integral of e raised to negative x over 3 dx from 0 to b. So, pwede nating i-let you dito yung mismong exponent ng e. Itong negative x over 3, right? Getting the derivative of both sides, we have du is equal to derivative ng negative x over 3 is simply negative 1/3 then dx. So, multiply natin both sides by negative 3. So, magiging negative 3 du is equal to dx, right? So that yung integral natin can be written as itong negative x over 3 is simply u, and then itong dx is equivalent sa negative 3 du. So, meron tayong e raised to u times negative 3 du. Itong negative 3, gigilid ko na lang sa magiging negative 3 integral ng e raised to u du. So, we have negative 3, integral ng e raised to u du is simply eu, right? And then, balik natin yung u in terms of x, equal siya sa negative x over 3. So, we have negative 3 e raised to negative x over 3. Then, tsaka natin evaluate sa lower at upper limit na from 0 to b. So, substitute natin yung b sa x sa magiging negative 3 e raised to negative b over 3 minus, substitute natin yung 0 sa x, negative 3 e raised to negative 0 over 3. So, simplify. Magiging negative 3 e raised to negative b over 3. So, ito is negative times negative 3, positive 3. And then, itong e raised to negative 0 over 3 is e raised to 0. Or, this is equal to 1, right? So, 3 times 1 or simply 3. So therefore, tsaka natin i-evaluate itong expression na to sa limit as b approaches positive infinity. So we have limit of this expression, so negative 3 e raised to negative b over 3 plus 3 as b approaches positive infinity. So, pwede nating i-distribute yung limit. So, limit of negative 3 e raised to negative b over 3 as b approaches positive infinity. Then, plus limit of 3 as b approaches positive infinity. So, itong expression na to, yung negative 3 e raised to negative b over 3, habang yung b natin is nag-a-approach sa positive infinity, anong magiging value niya? E raised to negative of, let's say, 99999 over 3. So, parang yung exponent ni E is negative of a large value. So, ibig sabihin, mag-a-approach yan sa 0. Okay? So, therefore, yung unang limit natin is equivalent to 0 plus, then limit nitong constant ulit na 3 as p approaches positive infinity is equal to the constant 3. So, that the final value is 0 plus 3 or 3. So, again, this improper integral is convergent at meron siyang value na positive 3. Okay? Next, we have integral of 3x over quantity 3x squared plus 2 to the cube dx from negative infinity to positive infinity. Okay, so this time, case 3 naman tayo ng improper integrals kung saan meron tayong lower limit na negative infinity at upper limit na positive infinity. So, gagamitin natin yung formula sa case 3 na to. So, copy natin. So, we will use this formula to evaluate this integral. So, equal siya sa yung first expression, limit ng integral, yung f of x dx natin, is itong expression natin, copy ko na lang. Then, from lower limit a to upper limit 0, then as a approaches negative infinity, plus limit nitong integral, so same expression, f of x dx, this time from 0 to b as b approaches positive infinity. So, evaluate muna natin tong parehong definite integral. So, dito muna tayo sa isa. Integral ng 3x over 3x squared plus 2 to the third dx from a to 0. So, pwede nating i-let you dito itong denominator natin, yung 3x squared plus 2. Getting the derivative, we have du is equal, derivative ng 3x squared plus 2 is 3 times 2x plus 0, or simply 6x, right? 6x dx. Okay, dividing both sides by 2, so we have du over 2 equals 6x dx over 2 is 3x dx. So, pag sinubstitute natin, we have integral of itong 3x dx is equal to du over 2. And then itong 3x squared plus 2 is equal to u. So, magiging du over 2, then u cube. So, itong 1/2, igigilid ko na lang, 1/2 integral ng du. Itong over u cube, magiging u raised to negative 3, right? Then, applying power formula, equal yung integral na to sa 1/2 u raised to negative 3 plus 1 over negative 3 plus 1. Simplifying, we have 1/2 u raised to negative 3 plus 1 is negative 2 over negative 3 plus 1 is negative 2 then. So, magiging 1/2 times 1/2 is negative 1/4 times 1 over u squared, right? Or gawin na lang natin negative 1 over 4 u squared. Then, yung u, balik natin in terms of x na 3x squared plus 2. So, magiging negative 1 over 4 3x squared plus 2 squared. Then, tsaka natin evaluate sa lower at upper limit from a to 0. So, substitute natin yung 0 sa x. So, negative of 1 over 4 times 3 times 0 squared plus 2 squared. Minus, substitute natin yung a sa x. Negative 1 over 4 3a squared plus 2 squared. So, simplifying, we have, so ilan tong expression na to? Negative 1 over 16, right? And then, negative times negative, positive, same expression. 1 over 4 3a squared plus 2 squared. Okay? Ngayon, para naman sa b, etong expression na to, same value lang din dapat yung integral niya, right? Etong nakuha natin na negative 1 over 4 times 3x squared plus 2 squared. Yun nga lang, yung lower at upper limit niya is from 0 to b. So, evaluate na lang natin yung same indefinite integral na negative of 1 over 4 3x squared plus 2 squared. This time, different yung lower at upper limit from 0 to b. Okay? So, substitute muna natin yung b sa x negative 1 over 4 times 3b squared plus 2 squared. Then, minus, substitute natin yung 0, negative 1 over 4 times 3, 0 squared plus 2 squared. So, ilan to? Negative 1 over 4 times 3b squared plus 2 squared. Negative times negative is positive. Then, ilan yung 1 over this expression? 1 over 16 din, right? So, therefore, tsaka natin kukuhain yung limit, itong unang expression, yung limit as a approaches negative infinity, and then itong second expression, yung limit as b approaches positive infinity. Okay? So, kapag in-evaluate na natin yung limit nitong unang expression natin, as a approaches negative infinity, and then plus, limit naman nitong expression limit nitong expression as b approaches positive infinity. So, pwede uli nating i-distribute yung limit, right? So, magiging limit of negative 1 over 16 as a approaches negative infinity plus limit ng 1 over 4 times 3a squared plus 2 squared as a approaches negative infinity, plus dito rin sa kabilang limit, distribute natin, magiging limit ng negative 1 over 4 times 3b squared plus 2 squared as b approaches positive infinity, plus limit of 1 over 16 as b approaches positive infinity. So, itong expression na to, dahil constant yung function natin, ang limit niyan is automatically equal sa constant, which is negative 1 over 16, right? Then, plus, itong expression naman natin, kapag nag-approach yung a dito sa negative infinity, then nakasquared pa siya, so, ibig sabihin, lalaki ng lalaki yung value ng a. Since nasa denominator siya, habang lumalaki yung ating denominator, lumiliit ng lumiliit yung value ng fraction hanggang mag-approach sa 0. So, therefore, yung limit nito is 0. Okay? Plus, doing the same analogy dito sa limit as b approaches positive infinity. So, same expression lang siya, right? So, therefore, pag in-approach nitong b, yung positive infinity, lalaki rin ng lalaki yung denominator. So, 1 over large denominator, is ibig sabihin, mag-a-approach din siya sa 0. So, 0 din yung value ng limit natin dito. So, plus 0, and then plus, limit ng 1 over 16 as b approaches positive infinity is constant din siya, so ang value din ng limit is 1 over 16. So, simplifying this expression, we have negative 1 over 16 plus 0 plus 0 plus 1 over 16. So, cancel yung 1 over 16, right? So, natira is simply 0. So, therefore, ito yung value ng limit natin, which is equal to 0. So, convergent yung improper integral natin na nagko-converge sa value na 0. Okay? Next, we have integral of dx over x ln x from e to positive infinity. Okay, so case 1 uli ito sa ating improper integrals. So, gagamitin natin yung formula for case 1. So, ito uli yung formula natin for case 1. So, equal yung proper integral na to sa limit ng integral. Yung f of x dx natin is itong dx over x ln x. Then, yung lower limit a natin is equivalent to e. Then, upper limit is b. And then, finally, as b approaches positive infinity. So, evaluate muna natin tong definite integral. So, integral ng dx over x ln x from e to b. So, pwede nating i-let you dito is itong, obviously, ln x, right? Kasi pag kinuha natin yung derivative of both sides, du is equal to derivative ng ln x is 1 over x. Then dx. So that pag sinubstitute natin, meron tayong integral ng itong dx over x is equivalent sa du. And itong ln x is equivalent sa u. So magiging du over u na lang, right? So integral ng du over u, alam natin equal yan sa ln u, right? Ngayon, ibalik natin yung u in terms of x, which is ln x. So, equal siya sa ln of ln x. Then, tsaka natin evaluate sa lower at upper limit na from e to b. So, substitute muna natin yung b sa x. So, magiging ln of ln b. Minus, substitute naman natin yung e sa x. ln of ln e. So, simplifying, ln of ln b, copy lang. Minus, ano yung ln ng ln e muna? ln e is 1, right? So, magiging ln of 1, and then ln of 1 is what? 0. So, therefore, makakancel tong expression na ito, matitira is ln of ln b. So, therefore, ang i-evaluate natin sa limit as b approaches positive infinity is this expression lang. So, limit of ln b as b approaches positive infinity. So, mapapansin nyo, pag sinubstitute natin yung big value ng b dito, kasi yung b is mag-approach sa positive infinity, anong value yung i-approach ng ln of positive infinity? So, palaki rin ang palaki, right? So, therefore, wala tayong finite value dito. Kasi, habang ina-approach nitong b yung positive infinity, yung magiging value nitong function natin is nag-a-approach din siya ng positive infinity. Palaki rin ng palaki. So, therefore, divergent itong improper integral natin. Wala tayong finite value sa given integral natin. Okay? So, this integral is divergent. Next, we have integral of sine x dx from negative infinity to positive infinity. Okay, so this time, case 3 ulit ito sa improper integrals. So, gamitin natin yung formula doon. Okay, ito yung formula natin kanina ulit, right? So, equal to sa limit ng integral ng f of x dx is sin x dx, right? Sin x dx from a to 0, then as a approaches negative infinity, plus limit ng integral, so same f of x dx na sin x dx din, this time from 0 to b, as b approaches positive infinity. So, pag kinuha natin tong definite integral, sa integral ng sin x dx from a to 0 is what? So, integral ng sin x dx is simply negative cosine x, right? Evaluated from a to 0. So, equal siya sa negative cosine of 0 minus negative cosine of a. Or, negative of cosine 0 is what? Cosine 0 is 1, right? Tapos times negative, so negative 1. The negative times negative is positive cosine A. Okay? Then same dito sa integral ng sin x dx from 0 to b. So integral uli niyan is negative cos x, right? But evaluate natin this time from 0 to b. So substitute negative cosine of, substitute b muna sa x cos b, minus negative of cosine 0 naman. So, we have negative cos b. Negative of negative is positive. Ano yung cosine 0? 1 ulit, right? So, therefore, equal to sa negative cos b plus 1. Then, tsaka natin evaluate yung limit. So, limit nung, para sa unang expression, ito yon, right? Negative 1 plus cos a as a approaches negative infinity. Plus, sa second limit, yung expression naman is ito, negative cos b plus 1, this time as b approaches positive infinity. So, distribute natin yung limit. Limit of negative 1 as a approaches negative infinity plus limit of cos a as a approaches negative infinity. Dito rin sa kabila, distribute limit of negative cos b as b approaches positive infinity plus limit of 1 as b approaches positive infinity. So, itong dalawang limit natin na constant, yung negative 1 tsaka 1, ang value niyan is negative 1, right? Tsaka 1. Then, itong limit ng cosine a as a approaches negative infinity. So, mapapansin nyo, kapag in-approach nitong a yung value to negative infinity, alam natin na sa cosine, meron lang tayong value na nagre-range sa negative 1 to 1, right? So, repeatedly yon kasi meron siyang period na 2 pi radian. So, ibig sabihin, wala tayong fixed value dito kasi habang binabago natin ng pababa yung value ng A, ang magiging value lang nitong cosine A is paulit-ulit na negative 1 to 1. So, walang defined value. Same lang din dito sa limit ng negative cosine B. Habang pinapataas natin ng pinapataas yung B, ang magiging value lang din itong negative cosine B is from negative 1 to 1. So, hindi define yung value kasi wala tayong finite value kundi pabago-bago. So, ibig sabihin, itong integral natin is divergent. Okay? So, this integral is divergent. Okay? Okay, so I think that's it for this video, Improper Integrals. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.